Hi everyone, it's Coach Fred, and today I'm going to be going over translations and reflections. And so you actually have done two Desmos activities on this, and you really saw some of the things that happened when you take a parent graph and you move it. Okay, so we're going to talk about translations, which mean move it left, right, or up, down, and a reflection. And we're going to specifically look at a reflection over the x-axis today. Okay, but as a reminder, get that investigation on parent graphs out, have it handy so you know what we're talking about, which graph we're talking about. So today we're going to be we'll start with the function f of x equals the absolute value of x. So we know that on this function we have some points. The points that we typically like to put into this function, inputs would be -2, -1, 0, 1, and 2, and therefore our outputs would be 2, 1, 0, 1, and 4, because absolute value is distance, and it takes, when you put those absolute value bars, it takes the positive. It only outputs a positive, so that's why we've got y's that are all positive. Oops, 2. All right, so when we look at g of x equals x plus 2, this is shifting the graph up 2 units. So let's think about that. Let's look at -2. If we shifted the graph up 2 units, would we be changing the x's, or would we be changing the y's? Hopefully you're recognizing we'd be changing the y's. So what's actually happening is all of our y's we're adding 2, but our x's are remaining the same. So I actually like to treat it like it's a rule. I'm going to add 2 to all of my y's, but my x's are going to remain the same. So it would be -2, -1, 0, 1, and 2, and my y's then would become 4, 3, 2, 3, and 4. So let's see if this was a shift up 2 units. So -2, 4, -1, 3, 0, 2, 1, 3, and 2, 4. All right, so yes, that's the absolute value function that's normally at the origin with its vertex shifted up 2. So again, we wrote a rule. If we think of these points as the points x, y, then the rule would be x, y plus 2. All right, let's try another one. So here we've got the absolute value of x plus 3. So the parent graph, y equals x, or f of x equals x. We plot our points. They're always going to be the ones that we thought were the most convenient. -2, -1, 0, 1, 2, and we're going to get 2, 1, 0, 1, 2. All right, so if we apply a rule here, this one's moving up 3 units. So all my y's are changing. So my rule would be x, comma, y plus 3. All right, so I'm going to apply that rule to the parent graph. And that's going to give me -2, -1, 0, 1, 2. And what's that? 5, 4, 3, 4, 5. Again, noticing the y's do repeat on the absolute value graph. So -2, 5, 1, 2, 3, 4, 5, that's right. -1, 4, 0, 3, 1, 4, and 2, 5. And you can see that we have the absolute value graph. All right, we moved these up. These last 2 up. We can also move a parent graph down. Let's look at a different parent graph. Let's look at the quadratic function. Again, I know this is a quadratic function because the highest exponent is 2, and I know its graph is a U-shape called a parabola. All right, so let me change that. I made a little mistake here, guys. It should say f of x equals x squared. All right, so this is like x squared, except it's going to be moved down 5 units. All right, well, let's talk about the parent graph, y equals x squared. The points we always agreed we were going to put on that one were also -2, -1, 0, 1, and 2. Those were good inputs. The outputs, though, would be different. They would be 4, 1, 0, 1, and 4, because we're squaring it. All right, so if this is shifting down 5, that means the y's are changing. So my xy would then change by the rule x, y minus 5. So I'm going to subtract 5 from all of my y's for my new function. All right, so that's going to give me -2, -1, 0, 1, and 2, and it's going to give me -1, -4, -5, -4, and -1. So let's see what we've got going on there. So -2, -1, -1, -4. So 1, 2, 3, 4. 0, -5, 1, -4, and 2. Oh, it was -1. So it was -2, -1, and 2, -1. So let me erase that. All right, so now, again, it's a parabola. So this one, we're looking for a nice U shape like that. Okay. All right. That's when we shift. Those are vertical shifts, up, down. Okay, vertical translations. Now we need to look at translations where we move left and right. So on the Desmos activity, you guys learned that was when it was on the, I call it the inside of the function. So here's an example. So now we've got g of x equals the absolute value of x minus 4, where the 4 is on the inside. So as you learned on the Desmos activity, this is actually going to move the parent graph to the right 4 units. It's the opposite. Remember, it's like putting what value you put in to get 0, especially if it's going to be moving left and right. All right, so we follow the same rule, but if it's moving left, right, it's not going to change the y's. It's going to actually change the x's, right? If I'm shifting left and right, think of the logic to that. All right, so we take our parent graph and our points on our parent function, -2, -1, 0, 1, 2. We're going to get 2, 1, 0, 1, 2. And our rule this time, though, is going to be I want to add 4 to all my x's, and I want to keep my y's the same. All right, so I'm going to make my table x plus 4y. X plus 4y. Let me change that, make it a little neater. Sorry about that, guys. It looks so messy. Okay, so I'm going to add 4 to all my x's. So that's going to give me 2, 3, 4, 5, and 6. My y's are going to remain the same. And so let's see what happens here. We get 2, 2, 3, 1, 4, 0, 5, 1, 6, 2. And I indeed have the absolute graph shifted to the right 4. All right, I'm going to pause there, and you guys are going to move on to the second video. Give yourself a quick break and stretch, all right? Have a great day.